This is the video for section 2.2, and here we're going to talk about trig functions for non-acute angles. In other words, for angles that aren't between 0 and 90 degrees. So to get to those, we're going to use what we call a reference angle. For any angle theta, the reference angle is written as theta prime, so it's theta with an apostrophe after it. This is the acute angle that's made by the terminal side of angle theta and the x-axis. When we look at the reference angle, we're always finding it with reference to the x-axis. So we always want to think of it as a positive angle that our original angle makes with the x-axis. We're going to look at what the reference angles would be for an angle in each of the four quadrants. And right now we're only talking about our original angle being between 0 and 360 degrees. We'll talk about later what we can do if the angle is negative or if it's more than 360 degrees. Let's start with the easiest one, and that is quadrant 1. So if our original angle is in quadrant 1, then the angle that makes with the positive x-axis is the same as our original angle. So this is the easiest one. Our reference angle is just equal to our angle. Then let's look at quadrant 2. In this one, here would be our original angle. It's going over here to quadrant 2. And then we want our reference angle to be the angle made by that terminal side and the x-axis. So that would be whatever completes this to go all the way around to 180. So if you look at this picture, the original angle plus the reference angle together make up 180 degrees. So we can write this little equation. So theta plus theta prime equals 180 degrees. And if we solve that for theta prime, we get 180 degrees minus theta. So that's our formula for finding the reference angle if our angle is in the second quadrant, is we just take 180 degrees minus theta. Now for each of these we've got the formulas written down, but I really suggest that at least to start with you draw the pictures. Sometimes this is a lot easier to see in the picture than it is by trying to memorize all these formulas. Now let's look at the third quadrant. In this case, here's our angle theta is going all the way over to here. And then the reference angle would be between there and the x-axis, so it would be from here to here. And if you look at what's happening here, the theta is 180 degrees, so it's 180 degrees from here around to here. And then after that, we've got our reference angle added on. So our theta altogether is 180 degrees plus our reference angle. And if we solve this for the reference angle, we get theta minus 180 degrees. Last of all, for the fourth quadrant, if we look at our fourth quadrant angle for theta, it's going around to somewhere over here. And then our reference angle is going to go from there up to the x-axis. So these two angles together end up being 360 degrees. If we write that as an equation, we've got theta plus theta prime equals 360. So the theta prime is going to be 360 minus theta. Again, it might be easier to figure this out from the picture rather than from the formula. Now let's look at some examples of finding the reference angle for a particular angle. The first two are both angles between 0 and 360. The first thing you need to know for this is which quadrant is the angle in. So in all of these I drew the picture. Again, I think that's really helpful other than just trying to memorize all these formulas. So in this one we've got 150 degrees for our angle. That's going to be in the second quadrant. And then our reference angle is going to be the one that takes it the rest of the way to 180 degrees. So looking at this picture, we can see that these two are supplementary angles. In other words, they add up to 180 degrees. If we were using the formula, we could take 180 degrees minus theta, or we could do it the other way and just set up that equation so that they add up to 180 degrees, and then we could solve it for theta prime. Either way, we'll end up taking 180 minus 150 degrees to get 30 degrees, and that's our reference angle. This angle, 215 degrees, is in the third quadrant. So here's our theta, and then our reference angle would be from the x-axis to the terminal side of theta. So in this one, we can see that if we took 180 degrees plus our theta prime, that would give us theta. So again, we're really setting up an equation, and then we can solve it for theta prime. So the equation would look like this, and then if we solve that for theta prime, we would have theta minus 180 degrees. Since our theta was 215, that would give us 35 degrees for our reference angle. Now these next two examples are both angles that are not between 0 and 360. So for these, the first thing we have to do is find the smallest positive coterminal angle to our original angle. So here's my picture. This is the negative 65 degrees. An angle that would be coterminal to that with positive measure would be 295 degrees. So all I did for that was take the minus 65 and add 360 degrees to get the 295 degrees. That angle is in the fourth quadrant. So one thing I could do is I could take theta, which was the 295 degrees, plus my theta prime, and those two would add up to 360 degrees. Then if I solve that for theta prime, I get 360 minus 295, which equals 65 degrees. This is doing it by using the formula. Another way to do this is if you look at this and notice that the reference angle turns out to be a positive 65 degrees. If you have a negative angle that's in the fourth quadrant, then the reference angle is just going to be the positive value of that angle. So we went from negative 65 degrees and the reference angle is positive 65 degrees. That only works if it's in the fourth quadrant, because for the other ones you'd end up with something greater than 90 degrees. And last of all, this angle is greater than 360 degrees, so we have to find a coterminal angle first. We can take our 413 and subtract 360 to get our coterminal angle. And if we do that, we get 53 degrees. That's in quadrant 1, so we don't have to do anything to find the reference angle. It's exactly the same as this angle. Our reference angle for this one then would be 53 degrees. Now we're going to use this to find trig function values for a particular angle. And this way is really nice because this means that you don't have to memorize all the values for the special angles all around the unit circle. First of all, we want to see which quadrant our angle of 210 degrees is in. If we draw this, it turns out it's in the third quadrant. So we've got our picture. Here's our theta, and our theta prime is from the x-axis to this terminal side. That means that we've got 180 degrees here plus our theta prime, and that's going to equal our theta. So if we solve that equation for our reference angle, we've got theta prime equals theta minus 180, which is 200 degrees minus 180 degrees. That gives us our reference angle of 30 degrees. Now we want to find the values of all 6 of our trig functions for 210 degrees. So to do that, we're going to find the values of all 6 trig functions for the reference angle for 30 degrees. And again, to do this, you can use that memory trick that gives you sine and cosine, and then you can get the other 4 from that. So sine of 30 degrees is 1/2. Cosine of 30 degrees is the square root of 3 over 2. And then tangent is sine over cosine, so that would be 1/2 divided by the square root of 3 over 2. That gives us 1 over the square root of 3, and if we rationalize the denominator, that turns into the square root of 3 divided by 3. For the other 3, we can just use the reciprocal identities. So cosecant is the reciprocal of sine. That would make cosecant 2. Secant is reciprocal of cosine. That would give us 2 over the square root of 3, or 2 times the square root of 3 over 3. And cotangent is the reciprocal of tangent. So taking this value for our tangent, if we flip that over, we get the square root of 3. Those are all for 30 degrees. The last thing we have to do is figure out what sign all of these functions have in quadrant 3, which is where our actual angle was. So in quadrant 3, only tangent and cotangent are positive. The other 4 functions are all negative. So I'm just looking at each one of these, and only tangent and cotangent are going to be positive. For the rest of them, I'm just going to put a negative in front of the value that I found. So for the sine, that's going to be -1/2. The cosine is negative square root of 3 over 2. The tangent is positive, so that's going to be the positive square root of 3 over 3. Cosecant is -2. Secant is -2 over the square root of 3. Cotangent is positive square root of 3. I've got lots of examples for these kind of problems because this is where sometimes it can start getting really confusing. So for this first example, we can see that our angle is not between 0 and 360 degrees. The first thing we're going to do is find a coterminal angle with that one that is between 0 and 360. To do that, we can just take our angle and add 360 degrees. That gives us 120 degrees. Then we're going to draw the picture. Here's our 120 degrees, and our reference angle goes from there down to the x-axis. So that means that these two angles together need to add up to 180 degrees. If we solve that for the reference angle, we've got 180 minus 120 equals 60 degrees. Now, since we're looking for the value of cosine, we would find the cosine of 60 degrees, which is equal to 1/2. Now we have to find the correct sign, positive or negative, for the angle that we started with. So our angle was in quadrant 2. In quadrant 2, cosine is negative. That means that the cosine of negative 240 degrees is actually equal to -1/2. This time our angle is greater than 360 degrees, so to get a coterminal angle, we're going to subtract 360 degrees. That gives us 315 degrees. If we draw the picture, that angle is in quadrant 4, and our reference angle would complete the circle to 360 degrees. So the theta and the theta prime add up to 360. If we solve that for theta prime, that means we're subtracting 315 from 360, and that gives us 45 degrees. Now we're trying to find the tangent. So the tangent of 45 degrees is the same as sine over cosine, and both of those are the square root of 2 over 2 for 45 degrees. So our tangent would equal 1. Now we have to look at what quadrant this is in. It was in the 4th quadrant, and tangent is negative in the 4th quadrant. That means our tangent of 675 degrees would equal -1. Now for part C, again, this one is greater than 360 degrees. So if we subtract 360 degrees, we get 420. That's still greater than 360, so we're going to subtract another 360 to get an angle that's between 0 and 360. We end up with 60 degrees. So here's our angle right here. That's in quadrant 1. When the angle's in quadrant 1, then it's equal to its own reference angle. So our reference angle is 60 degrees. The cosine of 60 is 1/2. All functions are positive in quadrant 1, so we've got the same sign for the value. So our cosine of 780 degrees is just equal to 1/2. For the last example, this time we have a negative angle. To get the coterminal angle, this time we want to add 360 degrees. That gets us to -45 degrees. And now there are two ways to do this one. Remember, for a 4th quadrant angle with a negative measure, we can just get our reference angle by taking off the negative. Theta prime would actually equal 45 degrees. Or the other way we could do this is by looking at our angle here, which would be 315 degrees. Then that and our reference angle have to add up to 360. Either way, we would get 45 degrees for our reference angle. We're trying to find cotangent, so the cotangent of 45 degrees is the same as cosine over sine of 45 degrees. Both of those are the square root of 2 over 2. So we end up with 1 for our value. Now in the 4th quadrant, cotangent is negative. To find our final answer, we would take cotangent of -405 degrees, use the opposite of our answer up here, so that would be -1.